Databases. Scary stuff. No, I'm kidding. Just kidding. There's nothing scary about databases. And in fact, that's exactly what this series is about. We're going to demystify your database. Good morning, Database Universe hitchhikers. Broadcasting from the 31st parallel, we bring to you the topic of SQL server performance, the logical perspective. I want to stress the word logical here. A lot of times we discuss the SQL Server performance, we talk about numbers, we talk about the most I/O consuming query, the most CPU consuming query, this query plan, that query plan. At the end of the day, the first and foremost, we have to go to the logical foundation of the SQL Server. What are you paying all that money for the SQL Server license? It's not cheap, but you're paying for a certain ability that it gives you, and that ability is first and foremost centered on your ability to use the relational logic. Now, I know there are people, they're going to throw tomatoes at me for saying this because many people don't consider SQL Server relational at all. But, we're going to sidestep that for a second. I'm going to pretend like it is, because really it could be. It's very easy to make it so. And that's sort of part of the problem, that it supports the ability of being a real relational database, but it doesn't force you to be that. And that's really the problem as far as performance is concerned. Because the whole reason why would you even go into the issue of working with the relational data and trying to stick to the relational data model is performance. And we'll get to that in a second. But let's start first of all from the most common problem that we deal with from the logical perspective, of course, the object relational mapping. The ORM is a very emotional issue. You hear people talking about it like it was the end of the world. I even saw an article that said, object-oriented mapping is the Vietnam of computer science. Come on, I think it's a little bit over the top. But, there's something to it. It's a very serious issue in terms of the conflict area between developers and database administrators. How is the object-related data going to map to the relational universe? And to me, it's very simple, because all you really need to do is remember 4 little letters: C, R, U, and D. CRUD. Create, read, update, delete. That's all a developer ever wants to do in your database. So let's put the warmongering aside and let's all be friends. We can make the same thing happen with regular ADO, with store procedures that cache their plans, you have good performance, parameterized queries if you have to go that way. There are very well-known and accepted ways of addressing this issue in performance. And I think it's just the matter of a psychological attachment that some people have that really push them into various frameworks that automatically do object relational mapping, but they pay for it in performance. In fact, not too long ago, I saw an article that Sony had to get rid of their relational database because of Hibernate. The Hibernate, which is supposed to be the relational mapper that is going to make your life easier, was not up to par when real performance was necessary. And you see that all the time, that when it comes to a database of 5, 10 rows, great, those relational mappers are fantastic. But when you start to get into the real world and you have online transactional systems that get thousands of transactions per second, then you really start hurting. And that's when you really need a DBA to patiently design this mapping for you for the best performance. You may say that this is not a cheap solution. Maybe, but the performance of it is unparalleled. And that really brings me to the set-based computation. The very reason why you're paying for SQL Server or Oracle or any other of those systems that allow you relational type of computation. Because the performance of the relational data model is unparalleled. You know, the problem is not new, obviously. The relational data model came about back in the late 60s. You know, Haight-Ashbury was rocking, Jimi Hendrix was burning up the Woodstock, everyone was having fun. But IBM and Ted Codd particularly were concerned with data problems. And their burning issue was the data performance. And none of these systems that they had were giving them acceptable performance, partly because the hardware was very weak compared to what we have now. But they solved it logically, not by muscle. And you see that a lot. People try to throw hardware at a problem. You don't need to. If you just use a little bit of logic to construct your data correctly, then you are able to see a boost in performance that is unparalleled. You can throw hundreds of processors at a problem and you're still not going to get the same boost as from a correctly, logically designed database. And this is why I have data modeling here as one of the logical issues, because some people even think that data modeling is a thing of the past. That's funny. That's not even reasonable. Why? Because if you don't model your data correctly, you're wasting your money that you spent on the SQL Server. The whole point that the SQL Server is going to be able to give you that boost in performance is based on your ability to make the data strictly relational so that you can perform set-based operations. So that, but if you just throw some things in tables and without any particular order, and you might as well use a Mongo or some no SQL DB. That why spend so much money on it? And that's really the bottom line of keeping the logical perspective, that you need to be able to properly structure your data, and then you will see a tremendous performance boost.